Okay, so in this video we're going to be looking at the scope and lifetime of both local and global variables, and we'll also look at this thing called the call stack. So let's get started. So the scope of a variable is just simply where in a program a particular variable can be referenced or accessed. So another term that we often talk about when we talk about a variable is its lifetime or duration. So the lifetime or duration of a variable is just simply how long it exists or persists in memory. So local variables are just simply variables that are declared within some particular function or block of code. And when we talk about a block of code, that could be a looping structure, a condition structure, so anything like that. And in terms of where they can be referenced from the point in which they were declared to the very end of that particular function or block. And their lifetime or duration is just from the point of entering in that particular function or block until the termination of the function or block. In contrast to local variables, we have global variables, and our global variables are declared outside of any particular function, and they can be accessed from anywhere. So it doesn't matter what function we're in, we can gain access to a global variable. Now, in a lot of cases, global variables will be constants. So in that particular case, we couldn't actually modify the variable, but we could still gain access to it. So in program 6, we actually declared a constant for pi, and we could access that particular variable anywhere. And that's generally how you're going to use global variables, is for constants. Your program should not have a whole lot of global variables, and in many cases they may not have any global variables. The last thing that I'll say about global variables is that they exist or persist in memory for the duration of the program. Okay, I want to talk briefly about memory and how whenever we compile a C++ program, the C++ compiler will actually allocate memory for different things. One thing it allocates memory for is for the instructions in our program, and this is what we call the code or the text area. It also allocates a portion of memory for our global variables. This is often called the static area. I'm going to skip over this particular area for now, but talk about the stack area. Sometimes this is called the call stack. So anytime we call a function, then we get a portion of this memory here associated with the stack allocated for the local variables and maybe the return values as well. So we're going to look at this particular area here, the call stack area, in more detail related to program 6. Now in terms of the free store or the heap, we'll come back and look at this a little bit later. But for right now we want to focus on the stack. We're going to look at program 6 and look at what's happening in terms of the call stack and also what global variables we have allocated. So in this particular program, we only have one global variable. So I'm going to go ahead and write that global variable for pi over here. And it was assigned the value of 3.14159. Okay, so when we start execution of this program, it starts in main. And so any of the variables that are defined inside of main, that would be considered local variables to main. And what happens is we'll actually get a portion of the stack allocated to the main function. So I'm going to go ahead and just draw a line here, and we'll say that this bottom part is just simply the memory that's been allocated for main. Okay, so this is where all of main's local variables will reside. And this can go by several different names. Some people call this an activation record. Some people call it a stack frame. I'm going to use the word stack frame and just abbreviate it SF. So all we're saying is this is main stack frame, and this is where main's variables live. So when we first enter into this particular function here, we'll have space allocated for the variable radius. We'll have space allocated for a circle and space allocated for a v sphere. Okay. Now how the compiler actually does that depends, but for right now we'll make this assumption that this particular compiler, when we first come into this function, it allocates space for these three variables. Now that doesn't mean that these variables are in scope. They only become in scope after you've actually executed the statement in which they were declared. So a circle wouldn't be available for us to reference until after this particular statement here. Same thing with v sphere. All right? And these particular variables can be referenced inside of this particular function and after their point of declaration. So you couldn't actually reference a circle or v circle in any of the other functions. Okay, so in this particular case, we're executing the first, we'll assume that we're executing the first statement here in main, and we actually get a call to another function called getPosInt. So what transpires is we get another stack frame. So for every single function call we have, we get another stack frame for that particular function. In this case, it's called getPosInt. So this is getPosInt stack frame. So this is where getPosInt local variables will go. So it has a local variable here in the formal parameter. So all of our formal parameters are considered local variables. And it also has another local variable called num. So we get space allocated here. Now, whenever this particular function was called, we actually passed a string value to it. So we pass in enter a positive integer for the radius of circle sphere to this variable called message. So I'm going to say that we have that particular string passed in, and it's just enter, and I'm not going to be able to write out the whole thing, but I'll just write the first couple of words, enter a positive. Okay, but assume that this whole entire string is being passed in. So we get a copy of that string passed to this variable called message. So whenever we execute this particular do while loop, we'll have cout and then enter a positive integer for radius of a circle sphere. Now, if they enter in a positive number, then we'll get kicked out of the do while loop, and we'll just simply return num. So we'll assume that they enter the value of 5 here for num. So when they input that value of 5, and it gets stored into the variable num. Now, one thing that you should notice here is that as we're executing here in getPosInt, vSphere, aCircle, and radius are out of scope. Even though they are existing here on the call stack, so they have life, but you're not able to reference those particular variables. That's something we need to keep in mind. So if we're in some other particular stack frame executing, then any of the other variables that were declared in other stack frames are inaccessible to us. So the last thing that happens here in getPosInt is we are going to return that value of 5. So that value of 5 is going to be returned down here to the main stack frame, and more specifically, it's going to be returned to the point of invocation where we have getPosInt. So as soon as this thing terminates, as soon as it finishes executing and it gives back that value of 5, then all of this stuff goes away. It gets removed from the stack, or what we say is popped off of the stack. So I'm going to go in here and actually erase this if I can. Let's see if I can erase this bit, and I'll erase this bit over here. Okay, so we now have, we've now returned control back to the main function. And what we've done is just simply return that value of 5. So that value of 5 was passed back. And so 5 is now going to be stored here in radius. And once we've done that, now we can execute area of circles. So this is another call to a function. So I'm going to go ahead and allocate that space back on the call stack here. So we get space allocated for this function called area of circle. So we have area of circle stack frame. And what happens, let me see if I can move down here a bit so we can read that a little bit better. Okay. So down here in area of circle, we actually have a formal parameter called r. So there's space allocated for r. And that's the only local variable that we have in this particular function. Now what happens is we're getting this value that was stored here in radius passed into, let me see if I can underline that a little bit better. So we're getting that value that was stored here in radius passed into this particular function here. And more specifically, it's being passed, a copy is being passed in here to R. So we can imagine that this 5 here, a copy of it's being passed up here to R. Now what you'll notice in this particular function is we actually call another function. So we're calling the pow function, or the power function, which allows us to take 5 and raise it to a particular power. So I'm going to go ahead and allocate space for that. So this does actually occur, even though we don't have the code for this. This is what's going on behind the scenes. We get space allocated on our call stack for pow. And so that 5 is actually being passed up here to this particular function. And it's just performing some operation in which it squares that value. And once it finishes squaring that value, then that stack frame gets popped off or removed. So let me go ahead and remove this stack frame. We'll assume that it's done its operation and it's squared that value. Well, I guess before we do that, let me do this. So if we squared 5, that would be the value of 25. So it's actually returning the value of 25. So the last thing it does is it returns this value of 25, and then that PAL function, all of its local variables and stuff, gets popped off of our stack. So we'll go in here and say that this thing has been popped off. All right. All right, so we're back down here in area of circle. So area of circle has calculated r squared, which was 25, because we used the PAL function there. And then we'll take 25 and multiply it by pi. So 25 multiplied by pi, I've already calculated that out, is 78.5397. So what's happening now is that we get that value being passed back. Let's see, let me get the right tool selected here. So we're getting that value passed back here to the point of invocation. So that value of 28.539 is being passed back. So once that area of circle function completes that calculation and it returns that value, it gets popped off as well. So I'm going to go ahead and remove this from our call stack. And we'll remove this as well. So this is basically our picture right now. We're back here inside of main, and we just calculated the area of circle based off of our radius of 5. And now we've stored that into a circle. So we have 28.539. Let me clean up some of this other stuff as well. This is actually not there anymore. Okay. So we have that, and now we're going to calculate the volume of the sphere. So we got to go and call another function. So we get space allocated once again on the call stack. So you can see that the stack is actually growing and shrinking as we call these functions. So now we're calling vol of sphere, which is down here. So let me write this. Vol of sphere. Okay, so this is vol of sphere's stack frame. And we notice here that vol of sphere also has a local variable called r. So this r here, or this r that's in vol of sphere, and this r that was in area of circle are totally two different animals. See, this r doesn't even exist anymore. And this r is now in existence since we just called vol of sphere. Okay, so we've called vol of sphere, and what happens? We actually are passing the radius once again, which has the value of 5. So that value is being passed up here once again to this particular function. So we get the value of 5 there. But this time, whenever we look at the expression that's being evaluated here, we have 4/3 pi r cubed. So once again, we get the PAL function that's created. So we got the PAL's function stack frame that's created for us on the call stack. And it receives that value of 5. And what does it do? It actually cubes that value. So it calculates the cube of 5, or it cubes 5, and so that's 125 that's being passed back. So once this thing calculates 5 raised to the 3rd power, it's going to return that 125 back. So what we're going to do is say that it's performed that operation and it's returning that value back, and it gets popped off of the stack here. So let's see if I can clean this up a bit. All right, so vol of sphere, once it has that value of 125 being passed back, it uses that 125 here, multiplies it by pi, and then multiplies it by, or maybe I'm saying this in the wrong order, it would take 4/3, multiply it by pi, and then multiply it by the 125. And that is calculated to be 523.598. So what happens is we get, we get that value that's being passed back here. So it's 523.598. Okay, so that's what's being stored there. So as soon as that value is returned, we get this stack frame being popped off or being removed from the call stack. So I'm going to go ahead and represent that being removed from our our call stack. Okay, maybe clean this up a little bit. So that 523 is being returned here to vSphere. And at that point in time, we have the radius area circle in vSphere. And at this point in time, we can just simply do these output statements using cout. So the area of a circle that has a radius of 5 is 28.539. The volume of a sphere that has a radius vSphere, so this would be 5, and vSphere would be 523.598. And notice how we can, in fact, reference these particular variables, radius and vSphere, because they were local variables that were defined inside of this function called main. So since we're now back executing in this particular function, we have no problem referencing those guys because they're now in scope. Now, as soon as we finish that and do the return 0, then everything here on main will be popped off the stack. So our stack frame will be clear of everything. So let me go ahead and remove that. Let's go in here. And at that point, our program has terminated, and we'll just return to whatever our environment was. So if we invoked this from a command line, it would be just returning control back to the command line. And that's basically it. So in this particular video, we looked at drawing out what was occurring on the call stack, looking at the stack frames, what was in scope, what had life. So anytime we saw a particular variable in the call stack, we knew that it had life. Now, it may not be in scope, but at least it was existing there in memory. And we also looked at global variables here. So I forgot about our global variable pi, but it was accessible throughout this entire program. So after our program terminates, then that space would also be given back. All right, so that's it.